Hello, CloudPedagogians. Welcome back to everyone. I'm so glad you have decided to join me in today's session. In today's session, we are going to learn compute service, which are container services on AWS. AWS offers a broad spectrum of compute offerings that give you the flexibility to choose the right tool for the right job. The three main categories of compute are virtual machines, containers, and serverless. There is no one size fits all service because it depends on your needs. The key is to understand what each option has to offer in order to build a more appropriate cloud architecture for your use case. In this, you will learn about containers and how to run them on AWS. Of course, EC2 is great for all sorts of different use cases, from running a basic web server to running high performance computing clusters as well. Although EC2 is incredibly flexible, reliable, and scalable depending on your use case, you might be looking at alternatives for your compute capacity. For example, let's say you are looking for a way to run containers at scale on AWS. Container provides you with efficiency and portability. Containers can host a variety of different workloads, including web applications, lift and shift migrations, distributed applications, and streamlining of development, test, and production environments. But what is exactly a container? While containers are often referred to as a new technology, the idea started in 1970s with certain Linux kernels having the ability to separate their processes through isolation. At the time, this was configured manually, making operations little complex. With the evolution of the open source software community, containers evolved. Today, containers are used as a solution to problems of traditional compute, including the issue of getting software to run reliably when it moves from one compute environment to another. A container is a standardized unit that packages up your code and all of its dependencies. This package is designed to run reliably on any platform because the container creates its own independent environment. This makes it easy to carry workloads from one place to another, such as from development to production or from on-premises to cloud. And in this context, I am specifically referring to containers like Docker containers. So, what is Docker? When you hear the word container, you may associate with Docker. Docker is a popular container runtime that simplifies the management of the entire operating system stack needed for the container isolation, including networking and storage. Docker makes it easy to create, package, deploy, and run containers. Then you may think, what is the difference between containers and virtual machines? Containers share the same operating system and kernel as the host they exist on, whereas virtual machines contain their operating system. Since each virtual machine has to maintain a copy of an operating system, there is a degree of wasted space. A container is more lightweight. They spin up quickly, almost instantly. This difference in startup time becomes instrumental when designing applications that need to scale quickly during input-output bursts. While containers can provide speed, virtual machines offer you the full strength of an operating system and offer more resources like package installation, a dedicated kernel, and more. AWS offers container services like Amazon Elastic Container Service, otherwise known as ECS, or Amazon Elastic Kubernetes Service, otherwise known as EKS. Both of these services are container orchestration tools. Again, what is this orchestrate containers are? In AWS, containers run on EC2 instances. For example, you may have a large instance and run a few containers on that instance. While running one instance is easy to manage, it lacks high availability and scalability. Most companies and organizations run many containers on many EC2 instances across several availability zones. In other words, when you use containers on AWS, you need to process to start, stop, restart, and monitor containers running across not just one EC2 instance, but a number of them together that we call a cluster of EC2 instances. The process of doing these tasks is called container orchestration. And it turns out it's pretty hard to do it on your own. If you have a few containers, it's not so bad. But once you get to hundreds or thousands of containers that you are managing, it can be quite complex. Orchestration tools were created to help you run and manage containers. If you are trying to manage your compute at a large scale, you need to know how to place your containers on your instances. What happens if your container fails? What happens if your instance fails? How to monitor deployments of your containers. This coordination is handled by a container orchestration service. AWS offers two container orchestration services, which is Amazon Elastic Container Service and Amazon Elastic Kubernetes Service. We will first try to understand how to manage containers with Amazon Elastic Container Service, which is known as ECS. ECS is designed to help you run your containerized applications at scale without the hassle of managing your own container orchestration software. It allows an end-to-end container orchestration service that allows you to quickly spin up new containers and manage them across a cluster of EC2 instances. To run and manage your containers, you need to install the Amazon ECS Container Agent on your EC2 instances. This agent is open source and responsible for communicating back to the Amazon ECS service about cluster management details. You can run this agent on both Linux and Windows AMIs. An instance with the container agent installed is often called a container instance. Once the Amazon ECS container instances are up and running, you can perform actions that include but are not limited to launching and stopping containers, getting cluster state, scaling in and out, scheduling the placement of containers across your cluster, assigning permissions, and meeting availability requirements. To prepare your application to run on Amazon ECS, you create a task definition. The task definition is a text file in JSON format that describes one or more containers. A task definition is similar to a blueprint that describes the resources you need to run that container, such as CPU, memory, ports, images, storage, and network information. As you can see here, it is a simple task definition that you can use for your corporate director application. In this example, it runs on the NGINX web server. Now we'll try to understand how to use Kubernetes with Amazon Elastic Kubernetes Service, which is Amazon EKS. Kubernetes is a portable, extensible, open source platform for managing containerized workloads and services. By bringing software development and operations together by design, Kubernetes created a rapidly growing ecosystem that is very popular and well established in the market. Of course, EKS does a similar like ECS, but uses different tooling and has different features. The way you interact with these container services is you manage the containers running on a cluster through the orchestration tools API. And then the orchestration tool carries out the management task for you. You can automate scaling of your cluster, hosting your containers, as well as automate the scaling of the containers themselves. If you already use Kubernetes, you can use Amazon EKS to orchestrate these workloads in the AWS cloud. Amazon EKS is conceptually similar to the Amazon ECS, but there are some differences. An ECS instance with the ECS agent installed and configured is called a container instance. In Amazon EKS, it is called a worker node. An ECS container is called a task. In the Amazon EKS ecosystem, it is called a pod. while Amazon ECS runs on AWS native technology, whereas Amazon EKS runs on top of Kubernetes. If you have containers running on Kubernetes and want an advanced orchestration solutions that can provide simplicity, high availability, and fine-grained control over your infrastructure, Amazon EKS is the tool for you. So finally, containers have a shorter boot-up time when compared to virtual machines. So if you need super fast response to increasing demand, then containers may be the service for you. So you can choose to host containers on top of clusters of EC2 instances as your hosting options for either ECS or EKS. However, if you were looking for an alternative to hosting your containers, because you either don't need access to the underlying operating system of EC2 or you don't want to manage that cluster of EC2 instances. Well, you can use a compute platform called AWS Forget, which handles most of the underlying details for you. Forget is a serverless compute platform for ECS and EKS. Alright, today we got to cover few more options for AWS Compute. I hope this is useful and helpful for you. When you are ready, please join me in my next lecture in my next video. Until then, take care.